Hi there, this is your moderator, Lori Dearmond with Webattract, your end-to-end solution provider for webinar demand creation, and you are in the right place for the business case for UV Maskants. Are you using the right mask? Sponsored by Dymax Corporation. Now, for those of you who haven't heard of Dymax, they're based in Torrington, Connecticut, and are manufacturers of UV light curable adhesives, coatings, oligomers, and compatible UV light curing and dispensing systems. In just a moment, I'll be introducing our panel of thought leaders, as today's webinar is about hearing from these experts as they reveal real-life examples with concrete numbers of how light curable materials have significantly increased productivity and reliability. Now, today we have a diverse audience of professionals representing a variety of industries, all here to learn techniques and see specific examples of how others have been able to significantly cut processing time, increase throughput, and dramatically lower manufacturing costs while using greener processes. So regardless of your industry segment or your location, we're confident that you'll find today's webinar of value. We would like to hear from all of you in the way of our very first interactive poll. So folks, coming up on your screen is that interactive poll, and we'd like to hear from you. What type of surface protection are you currently using? If you wouldn't mind sharing, and in this case, go ahead and select all that apply. Are you using lacquers, tapes, or wax, UV maskants, latex-based maskants, or perhaps something else entirely? All right, let's take a look at the responses. It looks like 20% saying lacquers, 80% looks like the highest, tapes or wax, 20% saying UV maskants, 24% latex-based maskants, and we already heard from many of our folks that indicated other. So I do thank you for letting us know. And with that, allow me to introduce our featured speakers for today. And they'll be passing the microphone between the two of them throughout, so I'd like to introduce both of them at this point. First, here we have Virginia Hogan, the Global Product Manager at Dymax Corporation, which includes support of the aerospace, automotive, energy, consumer electronic devices, and orthopedic implant industries. Virginia has over 13 years of experience with UV curable adhesives and 20 years of experience in the aerospace industry. Her efforts are focused on product line development to meet market and customers' needs with the next generation products. So welcome, Virginia. It is a pleasure to have you with us today. How are you?
I'm very well. Thank you, Lori, and thanks for everyone for joining us today. I'm really excited about this first series that we're going to be presenting today.
Absolutely. And folks, I'm also very pleased to introduce Irene Boutin, Application Engineering Manager for Dymax Corporation. And she manages a team of application engineers who interact daily with customers to help solve their complex assembly challenges. Irene has over 11 years of experience working with and recommending light curable materials and equipment for the medical device, appliance, aerospace, electronics, transportation markets worldwide. Irene and her team are dedicated to providing customers assistance with product and process design, testing, evaluation, and pre-production trials. So, Irene, also great to have you with us today. Welcome.
Hi, thank you. Thanks for joining us today, everyone.
Absolutely. And I'm going to go ahead and pass over to Virginia, and let's get started with the business case for UV Maskants. So, over to you, Virginia.
Thanks, Lori. Thanks to everyone for taking the time to attend the first of our UV light curable masking educational webinar series. I do appreciate your interest in our topic, so let's get started. Whether you're a Fortune 500 company, a startup, or any company in between, all these companies have one thing in common. Everyone's striving to achieve an increase in their profit levels. Annually, companies establish initiatives to increase profitability, improve efficiencies, incorporate greener processes, and maximize throughput. With the most challenging economic conditions faced in decades, manufacturers are aggressively looking for ways to reduce costs without sacrificing product quality. How can these initiatives translate to your bottom line utilizing UV light curable maskants? This is exactly what we want to talk about today, and I'm so excited to share this with you. In the manufacturing environment, process development starts with a concept, which is then converted to a design. taking into account product functionality. The development team transfers this design into a manufacturing process, specifying CNC machining centers, grinding machines, tooling, determining just-in-time takt time, as well as identifying other resources needed to complete the manufacturing process. A key part of the manufacturing process is surface treatment, which can increase the life of the product with a wear-resistant coating or plating, or surface texturing to increase bone growth in the case of an orthopedic implant. The success of a masking directly impacts the bottom line, either positively or negatively. Let's take a look at the challenges of a few conventional masking methods, which can be pain points in your process. Wax. First, you have to heat the part, then you have to heat the wax so that the wax can flow into the cavities or over the surface of the part. And then you have to wait for the wax to set up. With lacquers or latex-based maskants, the challenge is the dry time or the bake-off. The air dry each layer of the lacquer. It's like watching paint. You're sitting there forever. Tape is very labor-intensive to be applied and challenging for complex and intricate configurations, especially on multi-plane surfaces. If you look at the hip implant in the image on the left-hand side of the screen, thinking about applying the tape around that hip implant. So as you have to twist the implant to get 360-degree coverage with the tape is going to buckle. It's tough to get it to lay flat. Consequently, you may be having issues when it lifts during your process. So that is one of the challenges of tape. The second image on the right-hand side is a printed circuit board with connectors. The connectors have to be protected before the conformal coating can be applied. There's very little space in between the connectors on the board. Again, a challenge to be able to get the tape to provide the full protection that you need for the process. Did any of these sound like the challenges you face on a daily basis? Even a minute gap or void in the coverage can result in edge lifting and leakage that can significantly compromise protection and adversely impact your bottom line.
So Jenny, what are some alternatives for masking during surface treatments?
Lori, before we talk about light curable maskants, let's see how UV technology works. My colleague Irene will talk about how UV light curing works. Irene?
Thank you. The typical UV curing process focuses mainly on the UVA range with a 315 to 400 nanometer, as well as into the visible light spectrum. The proper wavelength along with the proper intensity are critical components of the curing process. Light curing materials are typically made of these basic elements. First, starting with the oligomer, which brings the basic properties such as chemical resistant or heat resistant. The monomer is used to add specific properties such as elongation, flexibility, adhesion to a specific substrate, or shrinkage. The additive is the fine-tuning for color, fluorescent, or surface finish. Some adhesives may have a tacky surface, as others may have a dry glass-like finish. The photoinitiator is the key for the ability to cure. All of these elements together become the formulation for the light curing material, but need the proper energy to complete the curing process. The photoinitiator package is designed around the spectral output of the curing equipment. Here you can see the peak at the 365 wavelength that aligns with the photoinitiator package of the adhesive, as you just saw in the previous slide. Formulations are designed for a specific type of curing mechanism. For example, a broad spectrum curing unit has a spectral output 315 to just over the 400 nanometer into the visible range. The photoinitiator will be optimized to match that same range. Now for LED curing, the wavelength is very narrow, or just one specific wavelength, like 365, 385, or 405 nanometers. Optimizing a formulation for LED curing means the photoinitiator package needs to match the same wavelength to initiate and complete the curing process. The UV curing process begins when the photoinitiating the light curing material is exposed to the proper wavelength and energy. Free radicals excited by the UV light exposure start the cross-linking process. This goes on to polymer propagation and final termination, meaning cure or converting liquid to solid. This is how UV technology works. So I will turn it back to Virginia to speak to Lori's question about the alternatives for masking during surface treatment processes.
Irene, thank you. The alternatives to traditional masking is UV light curable maskants. Now we've talked about how light curable materials are formulated and cured. Let's look at how UV maskants truly can impact your bottom line. Number one is increased productivity when converting from a manual process like tapes to a masking process with a long curing time and drying time like lacquers and latex-based maskants. This conversion will have a direct impact on your bottom line. The incorporation of light curable maskants can provide up to a 30% process savings over conventional masking methods. I'd like to go through and look at each of these elements of the benefits of light curing materials and how they can in fact impact your bottom line. First, let's look at on-demand cure, reducing the process cycles. 2, shorter process cycles translate to shorter production processes, specifically how this is addressed in future slides. Solvent-free for green chemistries, 100% solids. This is applicable when you have a light curable material versus a solvent-based lacquer or latex-based, where they're usually about 50% solids. So already you have savings right there from 100% solids to 50% solids. Lastly, inline inspection. Light curable process can be incorporated into an automated line with the dispense and cure versus having to have area for racking the parts as you would with something that has a long drying time. How can light curable materials help improve your surface treatment process? Before we can answer this question, let me introduce you to light curable maskants. Key differences to conventional masking options: cure on demand. As Irene explained the curing process, as soon as the masking is exposed to the proper wavelength, the cure starts. So within less than a minute, your product is available for the next process, rather than waiting for a very long dry time or a bake cycle. Conforming to complex configurations, as you see the knee in this image here, you see the different surfaces. The liquid mask conforms to these surfaces. Unlike the tape that had to go around the hip implant we saw on the previous slide, this liquid mask will conform right to these surfaces. And the most important part is that it's only one layer and one cure cycle. Key features of light curable maskants are visibility, the ability to see it during the surface treatment process. As you see in the image here on the right, this particular one has a yellow maskant, so you can visually see the mask on the part, where it is and where the protection will be. The maskants are thixotropic. That means that where you put them, where they're applied, they're going to stay, whether it's on a vertical surface or on a horizontal surface. It will stay in place. After the curing process and after your surface treatment process, the maskants can be removed either by peel or by burn off, leaving a residue-free surface for non-porous surfaces. The maskants are formulated to be solvent-free, 100% solids for greener processes, and RoHS compliant. Now that we've talked about the introduction of light curable maskants, I'll turn it back to Irene.
Right, thanks, Virginia. When applying the light curable maskants, the typical thickness can vary anywhere from 15 mils to 50 mils, and this is to provide the necessary protection during your unique surface treatment. The thickness requirement will vary depending on the surface treatment process, whether it's a light blasting or an aggressive chemical treatment. These maskants have been successful used to provide protection on features as small as cooling holes or as large as your dining room table. For the more complex components, as we saw in the image of the knee implant back a few slides, this implant needs protection on the top, sides, and edges, as well as the cutout in the middle. To achieve maximum protection on this component, a bead on the outer edges may need to be applied over the sprayed area to act as a barrier to prevent lifting during the blasting or plasma treatment. We just talked about the application of the maskants. There are many options to deliver the fluid to the surface of the component, from bead dispensing to spray systems or jetting. The dispenser on the top left side is mostly used for small areas, such as cooling holes or connectors on a printed circuit board, and using syringes as from the maskant package size. The spray gun in the middle, can be used as manual or an automated process with cartridges or pails for larger volumes. The jetting is a precision dispense of dots, beads, or a defined area and can be used semi or fully automated process. There are other manual methods to apply the light curable masking, such as brushes and dipping. While screen printing and foam rollers are not recommended because during this application method, it may create bubbles, and these bubbles may be a pathway for leakage. Curing equipment needs to be selected to meet your production needs. The UV light source is critical to the UV mask curing process. UV curing lamps and systems of various configurations and styles are commercially available. Spectral output of the lamp, intensity, component configuration, desired production throughput, and budgets are all factors that help determine which type of light curing system is appropriate. Complete cure of the UV masking resin each and every time is critical to achieve reliable and repeatable protection of the masked surface. The best source for assistance in selecting a curing system and qualifying a curing process is the manufacturer of the UV masking resin. Their expertise with both UV curing resins and curing equipment can help implement a complete optimized system that supports the masking process with minimal time and expense. All of this, of course, must be validated in the surface treatment process to ensure all performance requirements have been met. The final aspect of the masking process is the removal. Light curable maskants are formulated to be peeled, burned off, or water-soluble removal. Incineration cycles can be as short as 10 to 30 minutes in a 1200 degrees Celsius. This removal method is used in the aerospace and IGT industries for components that can withstand these higher temperatures. Touch-free removal options are available. These methods involve extreme cold, water, or air. The selection is dependent on what your component can be exposed to without harming the surface, texture, or soap component, as with a printed circuit board. These options range from exposure of the masked component to extreme cold, using dry ice, or to warmer options such as using a hot knife to assist with the removal.
Well, thank you so much, Irene. Very informative. And Virginia, if we could turn back over to you, and perhaps you could tell us where these products are currently being used.
Thanks, Lori. I'd love to tell everyone what industries are currently using light curable materials. These industries are aerospace, both on the OEM side and the MRO side, industrial gas turbine, again on the OEM side and the MRO side, The OEM is the original engine manufacturer, and MRO is maintenance, repair, and overhaul. These same light curable maskants are used in the orthopedic implant manufacturing processes, in glass fabrication, in the engines for railways, in the metal finishing industry, as well as in the electronics industry in the assembly of printed circuit boards for protection at the board level. Now that you know what industries are benefiting from light curable materials, I want to tell you about where and how the maskants are being used. First, airflow testing. If you look at the image in the top left-hand corner, that's a small airflow rig. In aerospace and IGT, on the hot section parts, there are cooling holes that are installed. Where the cooling holes are installed, the airflow can be measured. Some manufacturers measure mass airflow, where maskants aren't going to be used, but when they need to check the cooling holes on a row-by-row basis, each row can be masked off with a peelable mask and then peeled off to measure the flow from that individual cooling row holes. Next, if you look at the image on the right-hand side here for the plasma spray, thermal burial coatings are using light curable maskants for protecting cooling holes, leading and trailing edge, the tip, the edge of the platform, or even in the root. Light curable maskants are also used in grit blasting and shot peening, as you see in this image on the lower left. This is a grit blasting application. Here in this center image, CNC machining, polishing, grinding, laser drilling are all areas where light curable maskants are used. Here in the last image on this page is for chemical processes, whether it's anodizing, chemical milling, etching, acid stripping in the MRO industry, or in plating. Also, the light curable materials are used in protection for painting and e-coat. We've talked about where light curable maskants are used. I want to share with you a video that we have that will demonstrate the use of the maskants. Here you see a robot is picking up a tube that already has light curable maskant on it. If you can see the two ribs of blue, that is actually the light curable maskant. The robot is inserting the tube into a grit blasting process. You'll see the grit is coming from the nozzle here. Right here, these two rings of blue, that is actually the maskant that's been cured. As you can see in this grit blasting application, the mask is protecting the tube without lifting. The media is bouncing right off of the maskant. The maskant is holding up during this process and remains visible so you can see where the mask is and is resilient to this surface treatment process. We'll let the video finish up. I would like to let you know that this video is courtesy of one of our partners, Bachman Engineering, and they were kind enough to let us use this video to demonstrate to you today how the light curable maskants are used in the grit blasting process. The light curable maskants are also used in vibratory finishing. You see here in the tub here, for those that aren't familiar with vibratory finishing, it is a very large tub where media is put into the tub. It can be either plastic media or ceramic, and the purpose of this is to take very sharp edges and round them. So if you're putting a part in that has sharp edges, but there are areas on that part where you want to keep the sharp edges and not create a radius, you would mask that off. So in this case, the parts would be put into the vibratory finish, they would tumble around, and the media would create those rounded surfaces, and the maskant would protect the areas that need to have the sharp edges. These other images are from printed circuit board applications for coatings, whether it is a conformal coating or a Perylene coating. You'll see in this image down here on the lower left, this is an area where it was masked and there was not conformal coating added. This last image on the right-hand side is an area where the mask was used on connectors. This particular mask has a fluorescing agent in it, as Irene was talking about the additives. This fluoresces so you can see where the mask is after you removed it to make sure that there is no residue left. In this particular case, there's no residue left. Now I'm going to turn it back to Lori for another poll question. Lori, can you tell us about this poll question for our audience?
I would be happy to. Folks, coming up on your screen is that next poll, and we'd like to hear from you. What are the top challenges with your current masking methods? And you will notice that you're able to select all that apply, but we're going to ask on the honor system today that you give us your top two. Is it high labor costs, high rework and scrap, ease of use, low throughput, or maybe other? Okay, results are showing 48% saying high labor costs, 29% high rework and scrap, 42% ease of use, 42% low throughput, and 26% coming in with other. Ginny, any thoughts about these responses?
Sure, Lori. This is very typical of what we've seen, and the customer experiences that we're going to talk about are going to demonstrate that. But high labor costs is something that we hear from our customers that are impacting their bottom line, and they're looking for ways to increase profitability and reduce that. So this is definitely in line with what we've seen from the industry. So far, we've talked about techniques to enable faster processes, as many of you have indicated that that's exactly what you're looking for. Improving throughput with on-demand cure, greener processes with solvent-free resins. At this point, I want to tell you about 4 customer experiences that we've had that we were able to lower manufacturing costs and reduce waste in their manufacturing processes. So the first customer I want to talk about is in the orthopedic implant industry. In this particular case, if you see where the red oval is, this area is where it needs to be masked off. The balance of the part across the neck and the stem of this implant, that's where they're going to have surface texturing applied to it. The reason for the surface texturing is, as you can see here in the X-ray, when the patient receives the implant, there has to be growth between the existing bone and the implant. This texturing is going to create little nooks and crannies for the bone to grow into. So that surface texturing is essential for patient comfort after the implant has been received by the patient. Okay, here we're looking at what the manufacturer was doing, and they were manually applying tape. As you can see in this image, they're applying the tape as we had shown to you before, where it has to go around the 360-degree surfaces of the implant. The center image here, shows what it looks like afterwards. If you look here on the right, this is what it looked like after the UV material was incorporated. What did it do for our customer? In this particular case, the labor savings went from 10 minutes to 2 minutes for the application of the mask. They were able to eliminate the cleaning operation to remove the residue that the tape left and the drying time, so it resulted in a 3-minute savings per component. So based on 1,000 parts per month, this customer was able to experience 183 hours of available capacity for other new business. If you look at the rework and scrap savings that they had, they were able to reduce their scrap from 0.1% to 0 because they had a repeatable and reliable process. The tape wasn't lifting. The maskant covered the whole surface. So this translated for this customer of ours to an $18,000 reduction in scrap expenses annually. I want to take you now over to the aerospace industry. Here we have an application where they're masking off the root of a turbine blade. And this is in preparation for grit blasting and platinum plating. For this customer, their labor savings, the application of the mask was reduced from 30 minutes to 2 minutes with a semi-automated masking process. They also were able to eliminate the cleaning operation for the tape, so that 2 minutes was saved altogether. So for this customer, their savings was about 1,100 hours per month. This was based on a volume of 2,000 parts per month, giving them more available capacity to take on new business as well. Now, let's look at the rework and scrap savings. They were able to reduce their rework by 3 minutes, and they reduced their scrap from 0.1% to 0%. So the rework reduction equated to 100 hours a month, and they were able to have a $60,000 reduction in scrap expenses annually. Very happy customer after this. Now, the third example that we have is a customer that was masking a combustion case, as you see here, this part. Now, in this particular case, our customer was using 4 different thermal tapes for their plasma spray process. And it took them 15 hours to mask off 1 combustion case. Now, they had a requirement of 50 cases had to be produced a month, and this became very painful for them to mask up all these parts. It's a lot of hours, so they started looking for alternatives, and they wanted to have an automated process to be incorporated for the application of a mask. So we were able to help them out with this. The labor savings reduced the application of the mask to 1 hour, from 15 hours down to 1, giving them a savings of 14 hours. They also were able to eliminate the cleaning process, which was 30 minutes. So the savings for this customer was over 40,000 hours per year.
Now, Jenny, those are some amazing results and fantastic examples. And from our registration data, we know that many of the folks on today's webinar are from the electronics industry. And I know that you have a great example from electronics, so perhaps now's a great time for us to take a look at that.
Lori, I'd love to share this experience that we had with this customer from the electronics industry doing assembly of printed circuit boards. In this particular case, they are masking before conformal coatings. So their manual process was a latex-based masking, and this product had to dry. And so they had to rack up all the boards, and it would take 8 hours to dry. Whether it was 1 board or 100 boards, they still had to wait that 8 hours for each of these boards to dry so that they can move them on to the conformal coating process. The incorporation of the light curable masking was able to provide them a significant labor savings. So they went from 8 hours of waiting to dry before they could move their parts to the conformal coating. With the light curable maskants, they were able to reduce that to just 3 minutes. Huge, huge savings for them. They also were able to reduce their rework by 40% because they had something that was reliable. With the latex-based mask, they were experiencing shrinkage during that drying time, so that created the gaps around the mask. So during the conformal coating process, they would get coating in the gaps where the masking had shrunk. With the light curable material that has very, very low shrinkage, this was not the same case. So consequently, their rework was virtually eliminated. The masking process here with this customer, we haven't finished all the development, so the total savings I don't have for you because we're still trying to define an associated dollar value with freeing up the floor space that they no longer will need to use for the drying area for the boards while they're in queue before conformal coating. This is just a great example of how light curable maskants can provide advantages over traditional masking options. I'd like to just recap what we've talked about here. Process reductions, we saw with the customer experiences I just shared with you. Reliability, this was clearly demonstrated in the video with the blasting application where the cured maskant held up to the process without any lisping. Visibility, the UV light curable maskants are formulated to be visible in color so you can see the cured maskant. On-demand cure, with one layer with significant savings, as with the printed circuit board assembly manufacturer case that I just shared with you, or in the combustion case. I do hope that we've met your expectations by enlightening you on how light curable maskants provide advantages over traditional masking methods by enabling faster processing, increasing your throughput, lowering manufacturing costs with greener processes, as we demonstrated with our customer experiences. In conclusion, all companies, regardless of their size, are striving to identify and incorporate ways to increase their profit levels. Light curable maskants can be a means to your bottom line. At this point, I'd like to turn it back to Lori to talk about the next steps for you, our audience.
Absolutely, and thank you, Virginia, and Irene as well. And folks, before we get to all the great questions that are coming in our queue, allow me to share with everyone some ways that you can learn more and continue the conversation. As you know, there will be a recorded version of today's webinar that you can review yourself or send any colleagues who are not able to attend live today. Also, feel free to visit the Dymax website for lots of great resources. As well, there's a list of methods that you can use to contact application engineering over at Dymax to talk about your application requirements or any additional questions that you might have. I am going to ask both Irene and Virginia to step back to the virtual microphone, and we'll go ahead and start with the questions. So I'm going to go ahead and start with our first question, and this is going to be over to you, Irene. And the question is, can I cure the UV curable maskants with a black light?
Well, that's a great question. As we talked about before, the proper cure of the masking is critical to make sure that it withstands the process that it's meant to. So a black light normally does not provide the proper intensity or even the right wavelength for that proper cure. It's not recommended because the partially cured adhesive would probably not survive that process that it's meant to.
Okay, thank you. And the next question, I'm going to turn the mic over to you, Ginny, and would like to know, can I reuse the mask after it is peeled off?
That's a question we get a lot. I have to say no. Sorry, it's not a PSA. Once you apply it, cure it, it goes through your process. It is removed and it is not reusable.
Okay, I have a question here for you, Irene, from Derek. How clean does the surface need to be before application?
Another great question. The surface needs to be clean of oils or grease because you want the mask material to adhere to that surface. And when you have greases or oils on the surface, that's what the resin will adhere to, and that's compromise your bond strength to protect your surface that you're trying to.
Okay. Have another question here for you, Irene. How do you determine the required UV power, intensity, and cure cycle to make sure the material is cured? That one from Paul.
Okay. Hi, Paul. Well, it is something that we need to look at the process, but the best way to start that is to look at the product data sheet of the resin that you're looking at. That TDS does have some thickness and cure time guidelines, and it is just to be used as a guideline, but it's something to start with. And then you can cure your resin at 5 seconds, 10 seconds, and 15 seconds, put it through the process, and you're going to see that maybe at 5 seconds it does not survive. You're going to have lift on the edges or just total debond of the surface, where the 10 and 15 seconds you're going to have great protection and it's going to pass your process. So that's a good indication of where your cure time and thickness should be. You can also do the same evaluation at 15 mils, 20 mils, and 25 mils thick, and do those trials to really validate your cure time and thickness for the process that you want to use the resin for.
Okay, this one over to you, Ginny. Jeff is asking, what is the shelf life of mask, both unopened and after opening?
Great question, Jeff. Typically, our UV curable masks have a shelf life in the original package of 6 months to a year. In the unopened, keeping in mind that these are light curable materials, ambient light will start to react with the photoinitiator. So when the material is open to light, you want to make sure that it's in a protected environment, so that reaction that Irene talked about with the UV curing, that doesn't start. So Jeff, I hope that answered your question.
Okay, this one for you, Irene. Sam's asking, how do I know the material is cured?
To know if the material is fully cured, again, you need to do that cure time experiment using the product data sheet as a guideline, and then a cure at 5 seconds, 10 seconds, 15 seconds, and put it through the process. Again, at 5 seconds, you may have lifting on the edges, and at 10 and 15 seconds, you may have really good protection for the process. So that means that the resin is cured, and it gives you the protection required for that surface treatment.
Okay, this one for you, Jenny. Can I trim the cured maskant?
Thanks, Lori. Some maskants are in fact designed to be trimmed. Those that are trimmable, you would trim off the area to create a very defined edge, lift off the area that you don't want to remain on the part, and the maskant would stay in place until after the process. It holds that edge tension until you physically break that seal. So the answer is yes and no.
Okay. This one over to you, Irene, coming from Doyle. What is the max thickness and still cure the coating?
Here I am again. The thickness, again, you can use the product data sheet as a guideline because there is a chart with depth of cure of the resin. However, some of the resins do have a color for visibility, and they will have a depth of cure maximum. But so far, we have not seen any issues with the requirement thickness of a coating to protect the surface and having to do with the depth of cure deficiency on the product.
Okay. Over to you, Virginia. And Michael's asking, when we apply the maskant, how could we trim back areas with overspray, drip, rundown, etc.?
Michael, thank you for your question. As with our maskants that I had talked about previously, they're thixotropic. So there won't be any rundown. They're going to stay in place where you have applied them. As far as overspray, you can handle it two ways. One, you can take an alcohol wipe and remove the overspray before you cure it. Or if it is after the cure, then hopefully it's peelable and it can be peeled off.
Okay, one more for you, Virginia, from Derek. How thick can the mask be to be cured? There is an application where we might want to fill a connector to protect the contact pins.
Great question. In our maskings for connectors, most of the requirement is to have a mask that can cure anywhere from a 1/4 inch to a 1/2 inch, and the products are formulated to give you that depth of cure. And as Irene talked about before, the product data sheet, technical data sheet, there is a depth of cure chart on there, and you'll see that on light curable materials, most of them can be cured to depths beyond the thickness of the connectors. So again, Derek, simple, check the product data sheet. Most of the products for electronic maskings will have the depth of cure that you need.
Okay, got one here for Irene, coming from Midge. And Midge is asking, can this go through an oven, and what is the highest temperature it can take?
The material, the resins can go in the oven if it is part of the process. Keeping in mind that some of the resins can be burnt off. Virginia, do you want to?
Yeah, let me help you out on that one. Let's look at it at two parts. One, the maskants, because these maskants are 100% solids and 100% organics, they do combust. So in the incineration cycle that Irene was talking about, at 1200 degrees Fahrenheit, the maskants will in fact combust. If you're talking about going through a heat drying as you would with conformal coating, which might be at 93 degrees C, yes, the maskants will hold up to that. Many of them are designed to be flexible after exposure to heat. So depending on what process you're talking about for the heat, we would make sure that in your conversation with the application engineer that you select a product that will meet these process requirements.
All right. We'll stay with you for a moment more, Virginia. And Dennis is asking, for a sprayable coating, what is the application viscosity and temperature?
Dennis, excellent question. We get this quite often. Our materials range anywhere from 25,000 centipoise up to 110,000 centipoise. And a lot of people are looking at that viscosity and say, well, it can't be sprayable. Well, in fact, we do have spray equipment that can spray it. Now, keeping in mind a maskant, when it's sprayed, it will create what we would call an orange peel surface. So if you ever looked at an orange peel, you know how it has highs and lows and it's kind of bumpy? The maskant will look the same way. Keep in mind, these are temporary maskants. They don't have to look pretty, but they are functional. So you spray them at ambient temperature, and the viscosities anywhere from 25 to 110,000. Our spray equipment can accommodate anything in between.
Okay, one more for you, Ginny. And that is from Michael. Are there temperature or bath restrictions for the maskants?
Temperature restrictions, as we had talked about, when it comes to heat, it's going to be dependent on which maskant. Some are designed to have more heat resistant than others. The products go through plasma spray applications. In a plasma spray application, we know at the nozzle, the heat could be 800 degrees or higher, but at the workpiece itself, it's only 200 or 300, so it holds up to that. We have maskants that will hold up to processes where the workpiece itself could be up to 600 degrees Fahrenheit. As far as baths, in a chemical solution, typically the maskants that are chemically resistant, 200 degrees Fahrenheit, no problems at all. At that point, it's going to start to be a factor of temperature and duration that the maskant is going to be exposed. So that would be one of the things that in the conversation with the application engineer, we would need to understand what those process parameters are so we could pick the maskant that would make the most sense and be most successful in your process.
Okay, well, looks like we are getting to the top of the hour. Before we close up, I wanted to ask both Irene and Ginny if they had any final comments. Irene, anything on your end?
I just want to say thank you for everyone to take the time to join us today. And if they have any questions regarding their application, if they're not sure that if it works for them, please give us a call at our application engineering department. And either me or one of my teammates will be happy to talk to you and help you with your questions.
Perfect. And how about you, Virginia?
I just wanted to thank everybody for taking time. I know how busy everybody is, and it means a lot to us that you took the time to be interested in the light curable materials and join the session today. For those that we didn't get to your questions, we'll get to them via email, and I really appreciate all the great questions that came through today. And again, I hope we can definitely help you impact your bottom line with increasing your profitability.
Absolutely. And folks, we are at that time. Again, a thank you for joining us. Hope you found today to be of value. Special thanks to both of our speakers today, Virginia Hogan and Irene Booten, and the sponsor for today, Dymax. And again, as your moderator, this is Lori Dearman saying thank you and have a great rest of the week. Bye for now.